everyone. Today I'd like to introduce Lester March, who works at Ascent. He's a technical architect at Ascent. His key background is in infrastructure as code, mainly using Terraform. And today he's going to talk to us about Azure AI Foundry. So more a case of the infrastructure side, because kind of that's the bit that we're most interested in as well. How do we secure it? How do we integrate it into our networks and talk about some of the new features? Because as we know, it's changing all the time. So yeah. Lester also been doing talks at community events as well, so look out for his talks. The last one was on something called Terra Grunt, which was actually really interesting. So might pop up a couple of pictures up here as well. And yeah, Lester, do you want to introduce yourself and take us through what you're going to talk about?
Yeah, thanks, Mitesh. Yeah, so I'm a cloud architect at Ascent, have been for quite a few years now, and run the cloud and platform practice there. So I have teams of really excellent DevOps engineers, SREs, cloud infrastructure engineers, all doing some really good stuff, building all sorts of great platforms from MLOps with Azure Machine Learning all the way through to sort of modern application platforms with Kubernetes and everything in between. But as you can imagine, a lot of what we do nowadays is focused quite heavily in the AI space. We have some amazing data scientists, AI engineers, data engineers working in that space. And of course, that's all underpinned now by Microsoft's AI Foundry in the Azure world. But Azure Foundry is something that's been through several iterations, and there's been some changes. And actually, there's some interesting features within AI Foundry when you start to provision the infrastructure that can be enabled, not yet available through the portal, which I'll talk about today. So when you're provisioning these things with infrastructure as code, there's some really interesting capabilities, which I think infrastructure focused people or platform engineer type people will be quite interested in going forward, particularly with some of the EU regulations that have come out for the EU AI Act, which has now been formalized into ISO 42001. I think a lot of companies are going to start getting sort of regulated around their use of AI, and a lot of these features sort of tie into those regulatory requirements that I think we'll start to see. So yeah, got some slides I can talk over around some of the changes, and then maybe I can show you some of those features in action just very briefly.
Yeah, brilliant. No, that'll be really good. Yeah, so I forgot also to mention Ascent is one of our partners, so we've worked with Ascent on some of the infrastructure as code projects a while back. And yeah, so Azure AI Foundry, let's take a look at the slides. And yeah, so as you mentioned, it's changing weekly, probably. New things are happening all the time, so it'd be good to see.
Yeah, so this slide kind of goes through some of the major changes. I really wanted to piece this together because AI Foundry, like I mentioned, has kind of gone through several iterations. And in fact, AI Foundry as a sort of resource type or service in Azure has never really been its own thing. At the outset, you have what is now kind of referred to as hub projects or AI Foundry hubs, which is actually based on the Azure Machine Learning provider. So if you were ever to provision this previously using infrastructure as code, so Bicep or the AZ API provider for Terraform, that's the provider you'd be using. You'd basically be provisioning an Azure Machine Learning workspace of a particular kind, and that would deploy AI Foundry. Whereas that's changed recently. And so the new AI Foundry projects, or AI Foundry projects as they're sort of termed, are actually based on Azure Cognitive Services. So it's a cognitive services account of a particular kind. And I think there's a particular attribute called allow project management. If you set that to true, it will provision an AI Foundry instance rather than a standard cognitive services or AI services account. And this has been quite confusing because both of these are still available right now. So you could provision sort of two versions of AI Foundry depending on what provider you use. And each of them have sort of differing features. The hub version came out first based on Azure Machine Learning. And I think interesting to Azure Machine Learning is Azure Machine Learning in Azure has been around for a really long time. There's capabilities within that service for auto provisioning virtual machines for obviously training models, but more crucially, actually hosting those models. So if you work in an Azure machine learning workspace and you provision an online endpoint to host your model, what the machine learning service is doing under the hood is it's provisioning a virtual machine, running your model, and then making it available on an endpoint for people to use for inferencing. I think Microsoft's kind of idea initially with a lot of the AI Foundry and AI Foundry models was that they would kind of tack on to that service or that kind of workflow. So you would effectively download a model and it would be hosted effectively as an online endpoint as part of the machine learning service, but instead of sort of surfacing through the Azure machine learning GUI, it was surfaced through the AI Foundry one instead. And you kind of see how that manifests, because actually, if you look in the older hub-based projects, that service has something like 11 or 12,000 models available. Most of those models you do have to host yourself, and I think it leverages that virtual machine capability under the hood to do that. And that's actually in direct comparison to the cognitive services model, which doesn't have that kind of same compute capability. So the models available in the sort of new AI Foundry projects model are based on what's known as model as a service. So these are models that Microsoft are hosting. So these are the popular models that we all know, right? So they're the OpenAI models, things like Grok, the DeepSeek models, Mistral. These are hosted by Microsoft, and in effect, that AI Foundry project or that AI Foundry account is really more of a sort of billing container. A gateway to access those models and it's used for billing, and consequently that's why you only see sort of 100 models available in that new model. There's some other changes too, right? So things like prompt flow was sort of semi-popularized for a time through the old version of AI Foundry. It's not, I believe, coming to the new project version. As we know now with things like agents, there's maybe more modern, more thought about ways to orchestrate, prompts between different capabilities. And one of the actual side benefits is that because we're now using cognitive services for AI Foundry, a lot of the other types of models, so things like AI vision, speech, document intelligence, are baked into that same service that you're using for AI Foundry. Whereas before, if you were to provision AI Foundry and you wanted to use something like document intelligence, or frankly, even if you wanted to host one of the Azure OpenAI service models, you would still have to provision a cognitive services account and then link your machine learning workspace to cognitive services. And so in terms of infrastructure, as you can imagine, especially when we start to think about things like private networking, identity-based access between resources, there's a huge number of resources that need to be deployed, many private endpoints, many services needing access through RBAC to other services, and you end up with this kind of tangled web. So I'm not saying it's not completely like that now, but it's certainly a lot simpler since the move to cognitive services.
Right. So I did have a question on that, Lester. So if you wanted to use some of the document intelligence stuff, for example, or even vision, do you have to provision the AI Foundry as well, or can you just use that as a standalone thing?
No, you could use it as a standalone. So AI Foundry by default will provision a cognitive services account.
Okay.
So cognitive services by default has some endpoint for these AI services. If you want to provision a dedicated document intelligence service, you can do that. You would provision the way you tend to do that with cognitive services is when you provision the cognitive services account, there's an attribute called kind, and you can change that to use document intelligence basically, and you'll get a dedicated doc intelligence resource with an endpoint that you could use. So you can absolutely still separate these services out, but a lot of those capabilities are now baked into the new AI Foundry service.
Okay. So when would someone think of, okay, this is the time I need AI Foundry? Then what's the typical perfect use case for it? Everything to do with AI, or?
No, I wouldn't say so. I mean, AI Foundry is I think it's slowly becoming the new hub. I think if today, if you're saying, well, I just want to use document intelligence, I think the answer really is still to provision a dedicated document intelligence instance rather than an entire AI Foundry hub.
Yeah.
The reason I say that is partly because it's a bit more complicated you need to provision the AI services account, cognitive services account, but then under that you provision AI Foundry projects, if you like, and it's within those projects that you start to develop things like agents, and link up some of the other features that we'll talk about later. So it would probably be slightly too complex, really, if all you want is one of the specific AI services, so vision as well, for instance. But if you want to do anything today, I think with agents, if you're trying to build sort of agentic AI type workflows, even if you just want to host models for use, just an LLM with an endpoint to use, then AI Foundry is the go-to today. You can still provision the Azure OpenAI service as a dedicated piece, but I would say the model going forward, if you just want to deploy even an Azure OpenAI model, then AI Foundry should be the way to go.
Cool. Okay, thanks for that. So what will we see today then in this session?
Yeah, I mean, I'll go through a couple of slides. We've kind of talked about this already, just a little bit of a change in how this works now. So before, you had all of these separate services, each service had its own SDK. So like from a developer perspective, a little bit clunky to work with, whereas the new service, it sort of wraps this up into the Foundry SDK. You still got the Azure OpenAI SDK to use as well. But so it makes it easier from a development perspective to work with AI Foundry and those services within it. And like I say, because it's unified now on that cognitive service resource provider, a lot of the security and governance, obviously, we're talking about securing and governing a sort of single service rather than several. And there's some actually great integrations with some other features, particularly things like Fabric and some monitoring infrastructure as well. I mean, the other change that's happened, we'll talk a little bit about the way the models work. So obviously one of the main things you want to do with AI Foundry is deploy models, LLMs. But there's this kind of notion now of standard deployments. So previously what you would do is provision an Azure OpenAI service in a particular region, and you would have access to models available in that region. So commonly in the EU, people would be deploying in Sweden Central and have access to the latest models. That tends to be the region that gets the latest and greatest models first within the EU. And people might also have one in, say, UK South, if they wanted to keep their data local to them or relatively local to them. What's happened now is Microsoft has tried to sort of simplify, I suppose, that deployment process. So your AI Foundry instance might be in UK South, and you can technically use any model that's hosted anywhere, because remember, all of these models are model as a service. So Microsoft's hosting them. That model is served out of various regions, various data centers. The easiest option is global, so that one at the top. And what that basically means is that your AI Foundry instance in UK South might be served by a model that's hosted in the US. Now, obviously, because of things like latency, it will probably be processed as close to you as possible, but it's not a guarantee. It could be processed anywhere. And this is one of the options you get when you provision a model. You can choose whether it's global, regional, or within a particular data zone, so things like US or EU. Data zone, you're basically forcing it to be, in that case, within the EU. So even if you're hosted in UK South, your AI Foundry service, that model will be processed within the EU. So if you're using like the latest sort of GPT-5s, which are only available in Sweden Central, even though your request is coming from UK South, it will be processed in Sweden Central. So it's just something to be aware of. I think most people are fine with data zone. In some cases, though, people do have sort of
does that mean the data get sent over to Sweden as well? Customers, like the custom processing customer data, or let's say documents or something. Do we need to be careful of the zones in that respect?
Yeah, I mean, any prompt will be sent to those endpoints, right? So yeah, if you're sending sort of past text from a document over to an LLM, then yeah, that will be going over to where that model is hosted. There's points to be made there. So regional, of course, means that it will be processed in the same region. you'll see that this is not necessarily an option for many models, right? You need to, there's a large table on Microsoft Docs that says which models are available in which region. So right
Yeah.
now in UK South, you're not going to be able to provision sort of GPT-5 in a regional, as a regional option. If you're, if you provisioned AI Foundry in Sweden Central, that would be an option for you. The only thing to note with regional is that you need to go fully onto the provision throughput mode. So it's not something you can use with just sort of the standard deployment. So there's a bit of cost implication there. But the other one to mention actually is Foundry Local. So Foundry Local is something that you can install locally. So if you're really, really strict on the data residency requirements, you can even have AI Foundry running in your own data center.
Oh, nice.
And then obviously that data is not going to even leave your site or egress into the internet. So
Okay.
lots of options available, just something to be aware of with the routing, because I
Yeah.
think by default, a lot of models will provision the global mode. And if people aren't aware, and they're maybe working in an organization with, data residency requirements, then that could be problematic, right? Potentially.
Yep. Thanks.
The other mode or thing to consider really is like I say, PTU versus standard. This has kind of always been the case since Azure OpenAI service was a thing, right? So standard is obviously the default. It's basically pay as you go. Very, very useful for that kind of low, medium POC type workloads, right? Where those kind of requests are bursty. If you've got sort of one or two use cases, AI sort of apps in your environment using an LLM, then obviously standard is presumably fine. But as you start to scale, what you'll notice is you'll get kind of a consistent average of prompts and token usage within your organization, at which point you might want to opt for the provision throughput capability. So what we're really talking about here is this notion of a kind of AI landing zone. So rather than having several AI Foundry instances with several models for different applications, having a central AI Foundry resource, remembering that you're provisioning an account and then under that account, multiple projects. So each use case can have its own project, but ultimately each project is using the same account, and those models can be deployed at the account level. So as an organization, you can have a single AI Foundry in production with the models you want to make available to your applications. And then those applications can use that kind of same model. And with that model, then provision throughput starts to become, quite a useful option, because all of the requests effectively are going to the same sort of LLM endpoint, if you like.
So you wouldn't have an AI Foundry per application then in your
No, and
same
it's something no, ideally not, and it's something we commonly
Yep.
see, and it's actually something that was more common when it was Azure OpenAI service. So you would have sort of a development team say, oh, we're going to, enrich our application with AI. Let's just spin up, an Azure OpenAI instance alongside our app services or our container apps. That's fine, by the way, right? Like that's totally normal for sort of development and testing and POCs, etc. But when we start, like I say, to talk about productionizing these use cases, there are multiple reasons why actually having a sort of centralized resource, that kind of AI landing zone, if you like, can start to be of benefit. Partly that is to do with security and compliance. There's other pieces which I won't necessarily have time to talk about today, but using things like API management in front of AI Foundry is also extremely powerful. So funneling all of those prompts in the organization, whether that's from AI engineers and developers or AI enabled applications, funneling all of that through a single sort of API management gateway. You can log all of those prompts and the responses. You can do rate limiting based on token usage. There's a lot of great policies now within API management to sort of facilitate this notion of a centralized AI landing zone. But absolutely, you would ideally have this single AI Foundry resource with the models that have sort of been sanctioned for use in production.
But so you may have a staging one as well, though.
Yeah, you could do non-prod and prod. I think usually is reasonable.
Okay. Yeah.
With these kind of shared landing zone environments.
Okay, perfect.
But remember also that the projects themselves could be classed as an environment. So you might have an application, you might have a my app one dev project and a app one test project with, you know, different models maybe that you're testing with your application.
Okay.
But yeah, so the decision point really here, like standard is basically the go-to, except for cases where you start to really ramp up that use case. And maybe that is a single application that's being used by, you know, tens of thousands of users. Then PTU obviously can come into it too. But usually what we see is companies with many use cases, and the use cases start to rack up and the usage of AI tends to increase. Then having that centralized landing zone and using a PTU, using PTU on the models is where that starts to come in handy. And the final point, and it's probably the more interesting one, honestly, is real-time versus batch. Now, real-time's the default, right? That's what we know whenever you talk, if you're playing the agent playground or you even talk to ChatGPT, this is that kind of interactive, you know, real-time. You ask a question, it responds in real time to you. It's fairly low latency. And therefore it's useful for these kind of chatbot type apps, which a lot of people are building, or agents. But the other piece to really mention is that a lot of these models do support a batch endpoint, and the batch endpoint is really interesting because it's actually 50% cheaper per call. And there are actually plenty of use cases where companies maybe want to summarize like 10,000 documents a week. You know, think about, you know, sort of insurance companies, etc. You know, you don't necessarily need it to you don't need to send it a document and for it to summarize it immediately. You might want to just send a batch of documents for it to be processed. So obviously the downside, I suppose, is that you're not going to necessarily get that response. It might sort of process that in the next 24 hours. So if you've got a kind of interactive application that's expecting a response, obviously that's not going to work very well. But you can build applications around this. And the other piece is that it integrates with Azure Blob Storage. So you can have sort of a storage account with a sort of input container and an outputs container. You can dump a bunch of files into that inputs container, send it off to the LLM, right, to get processed or summarized, whatever you're trying to do with it. And it has integrations to be able to basically take the outputs of that and put it in that outputs container. So, and obviously, you know, with that at the sort of heart of your application, you can obviously have sort of event triggers based on, you know, when those output folders get updated. You could have Azure Functions fire off when that starts to happen. So you can imagine to start building a kind of cloud native application based on that sort of batch processing integration. And like I say, for those use cases, you can actually save quite a lot of money if you go with that kind of deployment model.
Excellent.
So, you know, in totality, then, you know, you basically end up with this kind of decision matrix, which is really around sort of usage and billing, right? Am I going to go with standard or PTU? Data residency requirements. So, you know, am I okay with, you know, models, you know, respond, or my data being sent anywhere in the world for processing? Does it need to be within sort of the EU or the US? Does it need to be even within my particular region, right? So thinking of places like Switzerland or Germany that have quite strong data residency requirements, maybe that data does need to be regional, in which case maybe I'm not able to use some of the newer models. I'm restricted then to the models available in those regions. And then obviously, I haven't put it on the slide, but the kind of ultimate data residency or data sovereignty solution then is Azure Foundry Local, where you can just run that locally in your own data center or even on your own machine, right? And then finally, you know, what type of workload are you running? Is it going to be an interactive type app that's fine with that sort of standard real-time responses? Or actually, am I doing some batch processing? In which case, you know, finding a model that supports a batch endpoint is really powerful, particularly for the cost savings.
And what's like the most common use case and setup that you're seeing, and which AI features are you?
I mean,
support?
it's, you know, today chatbots, you know, with a bit of RAG in the background, right? So retrieval augmented generation. So very commonly, what we see is, you know, some web interface with a chat interface. You know, whether that's a little widget on a website for customers to talk to an agent, or whether that's a sort of full-on ChatGPT style page where you can have conversations and store conversation history. And then, like I say, some sort of ability to upload documents, have them indexed in AI search, and then have the LLM be able to sort of answer more intelligently based on that that content indexing. But we do see some batch processing. Like I say, there are companies who have to process an awful lot of documents, and the ability for LLMs to do things like summarization is extremely powerful. Although commonly I would say we see more use of in that kind of batch documentation processing. We see a lot more use of things like document intelligence still, so a different kind of class of model, but less so for pure LLMs to be doing summarization. So yeah, just an example here of what you might see. So the top one, I've got AI Foundry deployed in Sweden Central, oh no, UK South, sorry. So this is UK South. I'm just deploying two different models. So you can see for GPT-4.1, this is a model that is available in UK South. So I get an awful lot of options here. In fact, at the bottom, you can see regional provision throughput. So that's exactly what we mentioned. That regional means I will be using an endpoint in UK South for my processing. So my data is never going to leave the UK in that case. Like I mentioned, the only option with regional is provision throughput. So I do need to commit to that kind of, that kind of usage. I have option for data zone, which means it will be processed within the EU. So that could be processed by any Azure region in the EU that has GPT-4.1, which I think is most of them now. So it could be processed in France Central. It quite likely will be processed in UK South just because of latency, but it could be processed in Sweden Central, Germany West Central, right? It's kind of abstracted from you in a sense with this new standard deployment model. And then you can see even GPT-4.1 has batch processing, so I can pick data zone or global batch, and then I've got global and data zone standard. So that standard or batch deployment model is available to me with that model. So one GPT-4.1 is a model quite flexible in terms of its capabilities. And then you've got some of the newer models here. So this was GPT-5. I don't know if this has changed now. Sorry, GPT-5 mini. This might have changed now. This was, a few weeks ago.
It'll catch up at some point anyway, won't it, to GPT-5?
Yeah, and bear in mind that, remember, this is from UK South. So if this was an AI Foundry instance in Sweden Central, I would have that regional option. I don't, because I'm from UK South. So it's saying the best I can do in terms of data residency is data zone, because Sweden's in the EU. Your AI Foundry is in the EU, so we can do data zone, but we can't do regional. And equally, that model, at least at that point in time, doesn't support batch processing. So that option is not available to me either. And even then, actually, you can see it doesn't support provision throughput at this point. So again, these things obviously change over time radically. And then on the sort of right side of the page, you've got an example there of, there's a page on Microsoft Docs, very extensive, that will show you which model is available in which region and which sort of deployment mode. So if you're worried about which models you can or can't use, then you can find that resource and it will tell you fairly quickly what's available to you.
And we can see that's showing August 2025, so it's now October 2025. So whenever you're watching this, it's probably changed and added new things.
Yeah,
as well. So
yeah, it's all changing all of the time. I mean, when I basically finished writing all of the Terraform code for provisioning AI Foundry using Azure Machine Learning, it all swapped to cognitive services. Wow. And then we had a sort of a larger than you might expect rewrite, which leads me on to the next piece, actually, because provisioning an AI Foundry account, provisioning a project is fairly straightforward, right? It's literally two resources. There's not a lot of attributes that you need. The only sort of interesting one actually is kind of on this slide, which is the ability to host agents in a VNet. So you configure that on the AI Foundry account. There's a property called network integrations, and basically you can pass in a subnet ID. Now that subnet ID, it needs to be a subnet that's delegated to container apps. So the Microsoft.app/environments delegation. And that's because agents run as a container app. So you don't see that container apps environment, you don't see the container app itself. But if you're going to do VNet integration, you need to pass in a subnet ID that is delegated to container apps. And when you do that, when you provision an agent in AI Foundry, it will be running in your own virtual network. And then obviously it's subject to any NSGs, UDRs, Azure firewall configurations, etc. So useful, obviously, from a network security standpoint. The other thing it's becoming more useful with, and something that I think is actually really important going forward, is with the agents, you're not necessarily just chatting to an LLM. Nowadays, with agents, you can give them tools, right? So you can point them to things like APIs or MCP servers or even databases. And if those APIs or databases or MCP servers are on premise, you obviously need an agent that is network connected into an environment where they can access those services. So I think this is quite an important feature. I don't think it's configurable right now through the Azure portal. So if you have an AI Foundry account, I don't think you can configure it that way. It has to be done through Bicep or Terraform.
Will it update through Bicep and Terraform if you run it again, or do you have to recreate your AI Foundry?
I haven't tried updating it from not having a VNet integration. You might have to recreate it. There's all sorts of fun weirdness with these things as they're so new. There are times where you do have to sort of delete the entire resource and have it recreated. AI Foundry is also one of those resources that goes into soft delete. So if you do end up sort of playing around with this and deleting things, just remember that you have to kind of go into all of your AI Foundries in the Azure portal, find manage deleted resources and purge it before you can recreate it with the same name.
I think this VNet integration is similar to the web apps as well. So if you integrate a web app into your subnet, you've got access to your private network resources, private endpoints, or things on premise. As long as you've got a VPN through.
Exactly that. And yeah, so if you're in a hybrid cloud scenario, you've got on-premise applications that you maybe want to integrate with an agent, right? So a lot of larger companies might have a whole bunch of stuff still on premise or in sort of private environments, but nevertheless they still want to start leveraging AI, and they're looking at agentic AI to perform some function. You can do that with the VNet integration, right? This is kind of the first step. If you can have these agents on your network, then they can call those APIs and tools as they're sort of referred to in agent parlance, right? You can leverage those tools from those agents, but it's no different to having a container app that you put into a VNet or an app service that you put into a VNet. The traffic will just source itself from the container app.
And the private endpoints, is that defined once in the AI Foundry, and anything it creates those for you, or do you need to manage those separately as well and put them into a subnet? I'm guessing that doesn't need any delegations.
So the resources at the top are different, right? So the piece at the bottom, the agent subnet, you can do on its own. I think you should have if you're doing that, you should have a private endpoint to AI Foundry, particularly in scenarios where obviously those agents might not be able to directly get out to the internet to get to the public endpoint. They would need a private endpoint to reach AI Foundry. The three other resources there, Cosmos DB, Storage Account, AI Search, is actually to do with another interesting feature called capability hosting. It's a bit of a weird name, but it kind of makes sense. What it means is that you are self-hosting basically the storage elements of AI Foundry. And so to go through those resources, Cosmos DB will be used to store any conversation history that's happened with any agent in any project. So behind the scenes with AI Foundry, when you provision it today, there is a Cosmos DB that stores all the conversation history. It's just that it's managed by Microsoft and you don't have access to it. You don't see it. Capability hosting allows you to bring your own Cosmos DB for exactly that purpose. And I can show you that in a second.
So there's equally, two in that case.
Yeah, I mean, the one, but the point is that you retain your data and you can access those Cosmos DB stores, and then obviously it's just a document database, right? So you can then query that yourself. You could maybe build in capabilities into your applications around conversation history based off of that data. So there is utility there, but also, from a compliance and security standpoint, it's again coming back to that notion of a shared AI landing zone. If you have a single AI Foundry service in production for your organization and a kind of single Cosmos DB, you'll see how it gets, how it gets divvied up. But basically, each project has its own set of containers in that Cosmos DB where all the threads are stored. So from a compliance perspective, you could obviously search that and make sure people aren't doing anything too malicious with those agents. Storage account and AI search is basically used for document uploads. So obviously AI search is used to sort of embed those documents or store the embeddings for those documents, which can obviously then be used. So again, with agents, you can obviously upload documents that then it can refer to as sort of a RAG type system, and AI search is principally used for that, as well as the storage account for the document uploads itself. So basically, capability hosting allows you to bring your own services for hosting your own data. So again, in these, you can kind of see the theme of the theme here is all about sort of data residency, data sovereignty, and that kind of private networking and compliance requirements, all the sort of boring non-functional stuff that us infrastructure people are sort of tasked with caring about, right? So and actually this whole mode that you see here is termed by Microsoft as the standard agent deployment model. So basically, if you're not doing this, if you're not doing the capability hosting, and if you're not doing the VNet integration, they actually term it, I think, the basic deployment model. It's just sort of the, almost, I'm not sure what that says about sort of dev versus production, but certainly if I was running a production system, I would want to go with sort of standard and above type deployment models. So yeah, I mean, that's all the slides I've got for this particular thing.
Thanks. Thanks for that, Lester. So now you're going to show us the AI Foundry and the capability hosting part of it. So let's switch to that demo now. Shall I bring that onto the stage now?
Yeah, go for it. Yeah, it's a really brief demo, just in respect of time, really. There's so much you could show with this, but I just wanted to show off some of the capability hosting features, because again, this is something that's
zoom in a little bit for us.
Yeah, of course.
Sorry.
Hopefully that's a little bit better. Hopefully that's fine.
Perfect.
Yeah, so so the capability hosting, it's not something configurable through the portal, just like the VNet integration. I think if I was to go into, let me move you over here. If I go into my AI Foundry, is it possible now? We'll see the networking. No, so there's nothing really here, is it? So you can kind of see it is there. I don't know if it's actually configurable. You can actually see, so this is called the standard agent service, so what I just mentioned, right? Whereas they've called it light agent service, doesn't support VNet integration. So it might be configurable now. A lot of this stuff is obviously changing on a weekly basis, but there's nothing here around sort of storage, for data. So I've got a couple of projects. You can see here as well, I've got my Cosmos DB, I've got my AI search, and I've got a storage account. So these are the services that I'm provisioning myself, again, optionally, right? Because I want to store my own data. And I've got a couple of Azure AI Foundry projects. And actually, just to sort of touch on the point before, if I go to this AI Foundry instance and I open this view, you can see that this is from the cognitive services provider, whereas previously it was Azure Machine Learning. So if I was to go into Foundry, again, I'll zoom in a little bit. Other things I've done, by the way, like other security features you can add, you can disable API keys, which means all of the authentication must be done through identities. So you need to provide role assignments to the services wanting to use these endpoints, or to the users indeed. And then under agents, I'll just quickly go in. I've got a couple here. I called one a Gen AI use case agent. One of the things, once you enable the capability hosting, that you will see is you'll see these additional properties here. Again, I don't think today this is configurable. So if I was to go new agent, I'm not sure. Well, the new agent, because it's associated with this project, that all of my agents in this project will get that, will be linked to those capability hosts. But you can see it's linked to an AI search instance and it's linked to Cosmos DB. I've picked a model. So this is a model I've deployed to the AI Foundry account. We're in UK South. I've deployed GPT-4.1. And all I've done is I've given it just an instruction. I've said it's an expert on Azure AI and Microsoft Copilot, and its goal is to help ratify some use cases. So what you can do obviously is try this in the playground. So remember, right now, this agent is actually running in a container app in my virtual network. So unfortunately, I haven't got any sort of local or demo APIs or something that I can link to this as tools today to show you sort of that, prove that out to you. But the interesting thing is this is running in a VNet. And I can start having a conversation. So I can say, like, as an insurance company, come up with a top 5 list of Gen AI use cases. And this will obviously start responding. Okay, thanks. Let's explore underwriting. So I can have a conversation as I would ordinarily do. But while I'm having this conversation, you'll see there's a thread ID at the top here. You've got things like thread logs, so this is quite intelligent stuff, and we'll kind of see this in a different form later. So from a developer perspective, quite nice to see. But if this is happening at scale, like how do I capture this? And so we'll come back to the Cosmos DB. I've given myself access to this, so I'll go into Data Explorer. You've got this enterprise memory database, and then within that there are several containers. You'll see at the start the container has an ID, and actually before I do that, let's just show off one of the projects. So we were in project number 1, I think. One of the properties on here is something called an internal ID. So this is just the reason I want to point this out is because it's important if you're going to do this as infrastructure as code. You'll see there's an internal ID, which is a little bit like a GUID, just without the dashes. So
do not show on the properties,
DD.
then you have to go into JSON.
You can get it from the properties when you do it. So it's just a GUID, but without the dashes. But you will need to add the dashes if you want to set up the permissions to Cosmos DB. So again, I can do a much longer deep dive session on the actual infrastructure as code if anyone's ever interested. But 28DD. So you can see here 28DD, but in a proper GUID format are the containers relevant to that project. My other project obviously has a different GUID. So each project gets 3 containers in Cosmos DB. And then basically we have, I think, the thread message store. If I go to items, you'll see critically each thread. So there's obviously a thread ID, which accounts for the thread. So what thread was this? CYY. If I go down here, I've got my conversation. So we can actually open these up and look at these.
Nice.
So you can see the first one actually is my initial prompt, and then you can see the next one is basically the system prompt. So the instructions, as it terms it in this. So the instructions were that sort of system prompt that I set. So it sends my initial response, initial prompt, then loads in the instructions, and then as you can see, I get the response that it sent back. And obviously, as the conversation continues, right, this all gets stored to that thread. So, like I said, there's if any developers are watching, like this is quite useful, right? You could hook into this. And the reason I say that really is because previously, developers were building their own sort of SQL database, let's say, and storing the threads and the conversation history in there, and then using that in their applications to sort of store a conversation history, very similar to what obviously ChatGPT does. With this capability hosting, it's becoming more of a built-in feature, that conversation history. And so if you're a developer, you could obviously leverage these kind of data stores now to have that same kind of conversation history thing. But like I say, also from a compliance or a governance standpoint, you've kind of got a log of these messages. Now, do you want to keep them forever? Probably not, right? So you'd obviously, have some process that's going to delete these after 30 days, 90 days, whatever. Cosmos DB obviously integrates really well into things like Fabric. So you could even pull these into Fabric and do some really interesting stuff. You could build some lovely Power BI dashboards if you're interested in sort of how Gen AI is being used in your organization. So the point is that there's some really interesting opportunities that can come off the back of actually these capability hosting features here. And the reason I wanted to highlight this today particularly was it ties in not only with that notion of data security and governance, but also with the kind of what we're starting to see. It's a really new feature. It's not something you can configure right now very easily. I think it's really interesting, and I think it's important as AI Foundry continues to develop. So yeah, that's what I wanted to share really.
In terms of governance and for that kind of stuff, can you like protect what people are asking it or what they're uploading? Can you do checks before it sends a response, or is that something outside of this thing?
There are protections. There's responsible AI policies, which I can't comment on too much at this point. Again, you can link our AI policies to AI Foundry, and you can customize those as well. There are protection features built into some of the models. So actually, if you explore some of the responses, and you actually see this, so if you put API management in front and you enable, you link up API management to application insights, you can see all of the requests and responses that go through API management. They get surfaced in application insights. And if you ever to drill down into those responses, you'll see in the response body, not only is obviously there the message that the LLM is sending back to the user, there is also the content filters. So you can see,
Okay.
simple Booleans like, has this triggered a sort of violence policy, yes or no?
Is that stuff built in, or something you have to switch on?
It's built in. You don't have to switch it on. It's
to a point.
I don't know. I don't know if it's built into like the models or whether it's built into the OpenAI service, but there is a sort of protection feature there.
Brilliant. Okay, no, thanks very, very much. That was a really, really good demo. It's good to see it actually in use and talk about the networking stuff, because that's the bit that way on our side. We're most interested in the private secure networking and things, kind of what we do. So it was really interesting to see that from that perspective. And yeah, so thanks very, very much. And yeah, everyone look out for Lester and go and see him doing his community events and doing his talks. And thanks very much for watching.
Cheers, Mitesh.
Thanks again. Thanks for coming.
Cheers.